Good day, students. You are welcome to today's class. This topic is a very broad topic, which we started from. Rotation, reflection. Also, we talk about enlargement, and today we are looking at stretching and shear. Today we are looking at what? Stretching and shear. The topic is what? Linear transformation, which is the application of what? Matrices. And in this aspect, we are looking at the specific objective that we need to achieve at the end of today is that we should be able to stretch object practically. We should be able to stretch object along the x-axis, also along the y-axis, and also along the x and y-axis simultaneously. Then the next one is that shear also means what? Distortion. To distort an object, to change the nature, the form of an object. For instance, you can have a rectangle. When you display a rectangle a little, it will become a parallelogram. So what you've done, you've what? Distort that object. You've distorted it, and in linear transformation, we call it shear. So we should be able to shear object along the x-axis and also along the what? Y-axis. So the first thing we are looking at is what? Stretching. When you talk about stretching, it is all about you making an object to extend in a particular direction. Whether is either you make it to extend in the horizontal direction, or you make it to extend in the what? Vertical direction, or you make it to extend by, in other words, when it is extending in the x and y axis direction, in some sense you are trying to create what? Enlargement. So therefore, I'm giving you these graphs for us to understand what is stretching. Now let us look at the first graph. This first graph, you find out that what? The coordinates of the edges of the unit square are what? 0, 0, 1, 0, 1, 1, and 0, 1. A stand for 1, 0, O stand for 0, 0, B stand for 1, 1, and C stand for 0, 1. Now when you stretch, now we are considering the stretching of a unit square along the x-axis. When you stretch the object along the x-axis, you find out that what? The point O and C will not extend. The only thing that will extend there is what? A and B. Line A and B will now make this square to look like a what? A rectangle, using this graph below. You find out that initially the coordinate of A is what? 1, 0, and the coordinate of B is what? 1, 1. But when you stretch it along the x-axis with a scale factor of k, that simply means that the x coordinate will increase by k. That is why the coordinate of A, instead of it becoming 1, 0, by extension it becomes what? K0. And B, instead of it to become 1, 1, by extension it becomes what? K1. So using this graph above, we should be able to construct a transformation matrix for stretching along the what? X-axis. So what do we do? The first thing you look at, what is the coordinates of point A? The coordinate of point A before transformation, that is before stretching, it is what? 1, 0. Now when it stretches along the x-axis with a scale factor of k, the coordinate of stretching becomes what? K0. But since we know that we are using A and C to form our transformation matrix, if you look at the diagram very well, you find out that C did not change. C remains where it is. So therefore, our transformation matrix for C is 0, 1, just as the object matrix. So now, the combination of the transformation column matrix of A and C give us the matrix of what? Transformation. So that means that M is our matrix of what? Transformation when it is stretched along the what? X-axis. Now I want to look at another scale factor, L, which the unit square is stretched along the what? X-axis. If the along the Y-axis, sorry. If you observe this, when you stretch this unit square along the Y-axis, you find out that there are 2 points that will change, but one will not what? Change. Point 0 and point A will not change, but point C and point K will change. So when point C and point K, let us look at the diagram below so that we can get it better. So when you look at point K and point C and point B, you find out that what? They are new coordinate after stretching along the y-axis. You find out that instead of C being 0, 1, it becomes what? 0, L. And instead of B being what? 1, 1, it becomes what? 1, L. So now the transformation for A, because A did not change, it is still 1, 0 is equal to what? 1, 0. But the transformation of C changed. That is why it becomes what? From 0, 1, it becomes what? 0, L. So the combination of the two transformations gives us what? 1, 0 and 0, L. So the second graph represents the stretching of the unit square along the what? Y-axis. From the matrices above, M is called the matrix of what? Transformation, or is called the transformation what? Matrix. I hope you are getting it, please. Pay attention, please. This topic is very, very essential because some of us will be writing some international exams, and that is where we fetch this topic so that you will understand it, and also you should be able to attempt questions perfectly. So now let's look at another thing again. We said considering the stretching of a unit square along the x-axis and the y-axis simultaneously. Let's assume that you put you want to extend this point along the x and y axis. That simply means that you are extending this shape. There must be an increase on the y axis and the increase on the what? X axis. So we consider that factor of increase in the x axis as k, and the factor of increase on the y axis as what? L. So looking at the transformation below, you find that when you increase the two of them, you increase the unit square along the x and y axis. Look at the coordinate you will have. The A coordinate becomes what? Point A coordinate becomes what? K0, and point C coordinate becomes what? 0L, and what? The coordinate of B becomes what? KL. But we should know that our transformation matrix is formed using what? The coordinate of A and the coordinate of what? The coordinate of A and the coordinate of what? C. So the transformation matrix of the transformation column matrix of point A and C gives us what? K0 and 0L. So that is why our matrix of transformation becomes what? K0, 0L. I hope it is clear, please, because you might have some exercise. They might ask you what type. You only carry out the calculation, but they might ask you what type of extension or what type of transformation is this. From the transformation matrix given to you, you should be able to tell them that yes, this is the transformation, whether it is by sharing, whether it is by what? Stretching. Please. Then the next thing, we are to consider one example to solve. You know, generally, I told you before that we have one general formula in linear transformation using matrices. The formula is what? Q is equals to MP. Generally, we know that what? M is the transformation matrix, P is the matrix formed by the object coordinate, and Q is the matrix formed by the what? Image coordinates. So using the image, our example one said what? A square OABC with vertices 0, 0, 0, 1, 0, 1, 1, and what? 0, 1 is transformed into a rectangle 0, A prime, B prime, and what? C prime by the matrix 3004. Then they say we should find the coordinates of what? 0a prime, b prime, and what? C prime. So for us to solve this thing successfully, we know that what? Q is the coordinate, is the matrices that carries the coordinate of the image matrix, and P is the matrix that carry the coordinates of what? The object coordinate. And M is the what? Transformation matrix. So if M is a transformation matrix, they gave us the matrix as what? 3004. So now P is formed using the coordinates of the object, which are what? 00, 10, 11, and 01. And Q now is the matrix of the coordinate of the what? Image. So now let's look at this. Q is equals to, instead of writing M, you put the word, the transformation matrix, and instead of you writing P, you put the word object matrix. I hope we understand the multiplication aspect of a matrix, which we've discussed from the beginning of the term. That when you are multiplying, the first row of the first matrix will multiply the first column of the second matrix, and the same that first row of the first matrix will multiply all the columns of the matrix before we will now move again to the word second row to multiply all the columns of the second matrix. So if you look at the multiplication there, 3 times 0 is 0, and 0 times 0 is what? 0. That's why we have 0 plus 0. Then the next one we said what? 3 times 1 is 3, plus 0 times 0 will give you 0. Then the next one is what? 3 times 1 is 3, and 0 times 1 will still give you what? 0. Then the next one, the last one is what? 3 times 0 is 0, and 0 times 1 is what? 0. So now I'm done with the first row. I'm going to the second row now. 0 times 0 is 0, plus what? 4 times 0 is what? 0. Then 0 times 1 is also what? 0. Why 4 times 0 is what? 0. 0 times 1 is what? 0, while 4 times 1 is what? 4. That's why you have 0 plus 4. And what? 0 times 0 is what? 0, while 4 times 1 is what? 4. And when you add them together, you will now have the matrix below. Q is equals to that. So when you have that matrix, you can from there now pick out the coordinates of what? 0, A prime, B prime, C prime, C prime. Just the way you arrange the word object matrix. I hope this example is what? Clear to us. So now let's look at the next we are looking at. The next is what? Shear. Shear, like I said before, is the distortion of original object by a factor. What do we mean by distortion? The distortion is that you can have a square or a rectangle, and when displayed at a particular edge, it will never be what? A rectangle anymore. It will not change its nature to either what? Parallelogram or kite. So now we are considering what? The shear of a unit square by a scale factor of what? K along the x-axis. So in that form, look at the square here. The unit square is in this first diagram. So now let's look at the second diagram of what? Distortion. You see, after distortion, you can't call this shape a square again because it has what? Changed its nature, which means that what? The opposite sides can be equal and parallel, but they are not perpendicular. Because what? In a rectangle, the adjacent lines are perpendicular. So therefore, because of this, we find out that the distortion is by what? A factor called what? K along the x-axis. So if you look at the coordinate of what? C initially was 0, 1. So because it was 0 when it was in the y-axis, but now it has been shifted a little bit out of what? Y-axis. So the coordinate becomes what? The K factor. And also if you look at what? B also what? Increase. Initially it is 1, then it has left 1 by a particular value, which is also equal to the what? The same value which is represented by what? K. That is why B becomes what? 1 plus k, comma, and 1. So the distortion here now, we can still use it to form our what? Our transformation matrix using A and what? C. So the transformation matrix for A, it is the same. Why? Because the distortion did not touch what? A. It only touches what? C and what? B. So since we are transforming object using matrices, we are also going to do the same thing to this. So you know that point A did not change, so that simply means that it is still what? 1, 0. Then because of what? Point C changed, a formula is also what? Given, which is what? Before the transformation and afterward transformation column matrix, which is now what? K1. So the transformation matrix combine the coordinates or the column matrix for both points to form the transformation matrix, which this one is what? Obtain 1, 0, K1. Correct? Let us look at, in this case, when you stretch object along a particular line, the line have a particular word, name they used to call it, which in this topic, it is called what? Invariant line. Invariant line. So this invariant line, it is the line in which the distortion takes place. So now in this case, the distortion takes place along the word x-axis, and it is known as what? The invariant what? Line. Correct? So the next thing we are looking at, it is what? The distorting of what? Object along what? Y-axis. If you compare this diagram and the previous diagram, for the previous diagram that we just dealt with, it will still give you the same what? Idea. So if you look at it, the display is by what? A factor called m, which have influence in the coordinate of A and also have influence in the coordinate of what? B. But what? O and C remains what? The same. So now, with this second graph now, we can now form our transformation matrix, where we said what? 1, 0 for that of A increase a little away from the what? X-axis, which made the factor of the x coordinate to be what? M, which makes it to be what? 1m. And the other one is what? 0, 1, and after enlarged distortion, it still remain what? 0, 1. So the transformation matrix is what? 1, 0, and 1m, and what? 0, 1. So now let's look at the what? Second example of what? Transformation. They gave us, in this case, I've not solved any problem like this. It's a little bit what? Demanding. They now gave us the coordinate of the image and the transformation coordinate. We are to find the coordinate of the what? Object. That is why I have to form a coordinate for a matrix called what? P. So that means that instead of us having 2, 3, it becomes what? A1 and A2. Instead of us having 2 B's, we now change it to what? B1 and what? B2. So by this formation of this equation, I knew that what? After multiplying the matrix, you can use what? Equality, the laws of what? Equality of matrix to what? Pass other what? Judgment. So the multiplication here, after the multiplication, this is what obtained by us finding the value which A1, B2, A1, A2, B2, C2, all of them, to know the value in which they represent, we will tend to form what? A simultaneous equation. When you form the simultaneous equation, solve it simultaneously. What I mean by solve it simultaneously? In this matrix, the first value seen is what? 0. That simply means that the coordinate of the first item in the second matrix will also give us what? 0. So when you are done, you take this first column, equal it to what? The first 0, and go down to the second value and what? Equal it to another what? 0. Then at the end of everything, this matrix has aid our what? Calculation up to the extent we obtain our what? coordinates, which are what? 0, 0, 1, 0, and 1, 1. I hope this thing is, you are getting it better. So, hope to see you in my Google Classroom, and I want us to have total engagement in our Google class, because we have to do some certain work during the weekend, and I also want to make record. I want to record your score because your CA is also coming up. So I want to record your score for my own assessment before the CA will come. So thank you for watching. Have a nice day. Bye.